In this video, I'm going to review how to solve literal equations. Literal equations are equations made up of mainly letters, and the goal is to rearrange the equation in order to solve for one of those letters by using numerous mathematical operations. In this video, I'm going to go through 8 examples, and at the end, I'm going to show you a technique on how to check your answer. In this equation we have PV equals nRT, and we want to solve for T. So when we have letters next to each other, that means multiplication. So we have P times V equals N times R times T. So our goal is to get the T by itself. So we'll go to the side that has T. We got nRT here. I need to get rid of those. Those are being multiplied by each other, so I need to divide. So if I divide this side by N and R, those will cancel out. I need to do the same thing to the other side, and then T will be by itself. So you just stuff with T over here and PV over NR. Okay, so all we did was rearrange this equation and have T by itself. So T equals PV over NR. In this one we have V equals 1/3 pi r squared h, and we need to solve for h. So again, letters next to each other means multiplication. So we got 1/3 times pi times r squared times h. So our goal is to get h by itself. So first I'm going to get rid of the 1/3. 1/3 I want to multiply by the reciprocal, which would be 3. So I'll multiply both sides by 3. That'll cancel out the 1/3. So now I got 3v equals pi r squared h. So again, we want to get the h by itself. So we got pi r squared. I can just divide those out to get rid of them. So pi r squared. That will cancel them out. And then do the same thing to the other side, pi r squared. And then we get our h by itself. And then 3v over pi r squared. In this example, we have A equals P plus PRT, and we want to solve for P. Now this looks a little strange. We got 2 P's, but somehow we need to end up with just 1 P. So when you have multiple of the same letter that you need to solve for, you need to factor it out. So if I look here, if I factor out a P, that'll give me P times the quantity 1 plus RT. Okay, so now I only have 1 P in the equation. And again, if it's next to parentheses, that means multiplication. So if I divide by that quantity, divide by 1 plus RT, they'll end up canceling that out. So that'll cancel out here, leaving you just a P, and then A over 1 plus RT. In this example, we have A equals 1/2 H times the quantity B1 plus B2. And we want to solve for B1. So B1 is in that parenthesis, so we need to get that by itself. We get the 1/2. Let's try to get rid of that first. We do the reciprocal, or just times 2. That'll cancel that out. I'll just give you, 1 for that. So that gives me 2A equals H times the quantity B1 plus B2. Now my goal here is get rid of the h. I just divide it because it's currently being multiplied, so I do the opposite. That'll cancel out the h's. So now I have 2a over h. And then since there's nothing else on this side other than the b1 and b2, I can get rid of the parentheses. So b1 plus b2. So now I just have b1 plus b2. I can subtract b2 from both sides. So now I have 2a over h minus b2 is equal to b1. Now typically you want to combine the 2a over h and b2. In this case, they have a common denominator of h. So you have 2a over h minus b2 h over h equal to b1. And then you get two fractions with the same denominator. So you just add or subtract the numerators together. So 2a minus b2h over h. And that's going to be equal to b1. So for this equation, we have y minus y1 equals m times the quantity x plus x1. So our goal here is just to solve for the x. Okay, so for this one, the x. So the first step I'll do is get rid of this m. So that's currently being multiplied, so I'll divide it by m. So divide both sides by m. I have y minus y1 over m equal x plus x1. And since those are the only things on that side, I don't need the parentheses anymore. And then get the x by itself, and you subtract the x1. So that gives me y minus y1 over m minus x1 equals x. And again, I want to combine this into one fraction, and our common denominator will be m. So it could be y minus y1 over m minus x1 m over m to be equal to x. And I can combine those, y minus y1 minus x1 m all over m is equal to x. So in this one we have f equals 9/5 c plus 32. We want to solve for c. So I'll go to the side that has the variable that we want to solve for, get rid of anything that's being added or subtracted first. So we got plus 32, so I need to subtract 32 from both sides. So now I have f minus 32 equal 9/5 c. Now I need to get rid of that 9/5, so I'm going to multiply by the reciprocal, 5 over 9 on both sides. Alright, so that's going to leave me with 5/9 times f minus 32 is equal to c. So the c is by itself, so we're all done. Now this one has p equals r minus c over n. We want to solve for r. So my first step here, I want to get rid of that n on the bottom, so I'm going to multiply both sides by n. That's going to cancel that out to 1. So we got p n equals r minus c. And I want to get the r by itself, so I'm going to add c to both sides. So it's going to be p times n, or pn, plus c equals r. So here we have x over a plus 2 over b equals 1/2. And we want to solve for a. So a is on the bottom here. So we need to get that to the top and then get it by itself. So again, if you have fractions, our goal is to get rid of fractions. Makes the problem easier. And we need to find a common denominator. So we got a, b, and 2. So our common denominator would be 2ab. So I can multiply every fraction by 2ab. So 2ab times x over a. And then 2ab times 2 over b. And then 2ab times 1 over 2. Okay, so this first one, a, is going to cancel out, leaving with just 2bx. Over here, the b is going to cancel out. So 2 times 2 is 4, so 4a. Over here, the 2 is going to cancel out, leaving with just ab. So far I have 2bx plus 4a equals ab. Now I want to solve for a. I have two a's in here, so I need to get those together so I can factor out the a. So I'm going to subtract 4a from both sides. So leaves me with 2bx equals ab minus 4a. Now if I factor out an a, that leaves me b minus 4. And just bring down the 2bx. And then get the a by itself, I'm going to divide by b minus 4. And cancel out there. So we have 2bx over b minus 4 is equal to a. Now, at the end here, I wanted to show you how you can check your answer, see if it's correct. So one of the problems that we did, we started with p equals r minus c over n. And we ended up with r equaling pn plus c. So the way to check your answer, I'm going to plug in values in this first equation and then make sure it works out in the resulting equation. So if I choose 10 for r and 6 for c and 2 for n, ten minus 6 is 4, 4 minus 2 is 2. Okay, so basically I'm going to put in numbers into the equation to make it work out. So our 2 is p, 10 is r, 6 is c, and our n is 2. If you plug in the same numbers into the other equation, it should work out also. Okay, so we had 10 for r, so that's 10. P was 2. N was 2. and C was 6. So 10 equals 2 times 2 is 4, plus 6, and 4 plus 6 is 10. So both sides work out, so our answer is correct. Now if it came out with a different number, then somewhere along the line we made a mistake. But here, both sides came out to the same number, so we know our resulting equation is correct.